This activity is titled Journey to Mars. We gave it this title based off the task we set to engage students with digital technology. In this activity, students examine technologies that have been used for Mars exploration to stimulate thinking and problem solving as they endeavour to design and create their own technology system appropriate for exploring the unique atmospheric and ecological disparity of Mars itself. The activity required students to learn how to construct a buggy using EV3 Mindstorm materials, make adaptations to it that would suit their Mars endeavour, then finally reflect on the designs and discuss further changes. In the first lesson, students were familiarized with the construction and functionality process of EV3 Mindstorm technologies and how to code them. This started with explicit teaching and visual demonstrations before the cognitive load of the activity was gradually passed over to the students themselves. The students observed and performed the processes of linking the Rotobot devices to iPads using Bluetooth, which contributed to developing their knowledge and understanding skills within the curriculum. The students designed branching sequences to form algorithms that would help make a checklist for testing their motor functions of the device, observed, communicated, and documented how touchscreen icon symbols can be a better alternative to former interfaces, practiced the concept of iteration through repetitive movements of the robot with coding sequences, and explored how the icons can be universal language by breaking down their characteristics.
The second lesson in the Journey to Mars activity has been structured to develop students' knowledge of common digital systems, in particular EV3 LEGO Mindstorms. Expanding on the teachings derived from the first lesson, students will expand their understanding by investigating how users manipulate and customize codes to achieve desired outcomes. This will be achieved by evaluating the success of the predetermined robot created in the first part of the activity. Students will use their knowledge of the EV3 LEGO Mindstorms hardware and software to enhance the structure of the bot. This will strengthen students' adaptability and problem solving skills. Students will also increase analytical abilities through planning, creating, and communicating ideas and information using various technology devices. Within the design stages of the activity, visual arts have been applied within the lesson when creating the illustrated version of the final Mindstorm, which will be constructed in the final learning sequence.
During the first stage of Lesson 3, students will collaboratively construct their buggies using relevant ideas, information, and technological and digital terminology. In doing so, students will have to comprehend and identify how the internal and external components of their Mindstorm's EV3 LEGO digital design best satisfies the intended purpose of the activity. They will then analyze these components alongside their specified extension kit materials to form an explicit understanding of fundamental digital concepts. During the final stage of Lesson 3, students will have to undergo an evaluative process, individually and collaboratively reflecting on both their design and role in the production of their design, asking and answering questions which both critically analyze and improve on student solutions and their own design rationale. This allows students to formally investigate both the sustainability and efficiency of their design relevant to its intended purpose, thus strengthening their digital and scientific comprehension.